Good morning. Now that we have seen the impact of jet on plates, let us go to turbines. So what are turbines? Turbines are the hydraulic machines which converts hydraulic energy into mechanical energy. And this mechanical energy, what is it used for? That is used in running electrical generator which is directly coupled to the shaft of the turbine. Thus, the mechanical energy gets converted into electrical energy. So, as you know that turbines are machines which converts hydraulic energy into mechanical energy, whereas pumps, which we will be dealing in the next unit, those are machines which convert mechanical energy into hydraulic energy. So these are the parts of a turbine. Generator, that is a turbine. You have the wicket gate, rotor, stator, turbine generator shaft, and the turbine blades. This is a general schematic diagram of a turbine. Before going on to the details of turbine, let us see how turbines are classified. So there are there are various criteria for classification of turbines. According to the type of energy at the inlet, we have impulse turbine, example is Pelton wheel or Pelton turbine. And what are impulse turbine? If at the inlet of turbine, the energy available is only kinetic energy, you call it as an impulse turbine. Whereas reaction turbine, you have the examples of Francis turbine and Kaplan turbine. In this case, at the inlet of turbine, water will have both kinetic energy and pressure energy. And those turbines, you call it as reaction turbine. So this is the classification according to the type of energy at inlet, whether it is kinetic energy alone or it's a combination of kinetic energy and pressure energy. The second classification is according to the direction of flow through runner. So we have tangential flow turbine, that is, if the water, from the name itself you can understand, if the water flows along the tangent of a runner, the turbine is known as tangential flow turbine. Example is a Pelton wheel. Then you have radial flow turbine. If the water flows in radial direction through the runner, the turbine is known as a radial flow turbine. You have an example of Francis turbine. If the water flows from outward to inward radially, the turbine is known as inward radial flow turbine. And if the water flows from inward to outward radially, you call it as outward radial flow turbine. Yet another flow turbine is axial flow turbine. From the name itself, you can understand if the water flows along the direction parallel to the axis of rotation, you call it as axial flow turbine. And example is Kaplan turbine. And the last one is mixed flow turbine. If the water flows in radial direction but leaves in the direction parallel to the axis of rotation, the turbine is known as mixed flow turbine. And example is modern Francis turbine. Yet another classification of turbine is based on the head available at the inlet of turbine. The first one, you are having high head turbine, in which the head varies from 250 meters to 1770 meters, and the example is Pelton turbine. Then we have the medium head turbine, for which the head varies from 60 to 250 meters. Francis turbine as an example. And the third one will be the low head turbine, which is having a head of less than 60 meter, and example will be Kaplan turbine. Yet another classification is based on the specific speed of the turbine. If we have low specific speed turbine, for which the speed is 9 to 50 revolutions per minute, Pelton wheel as an example. Medium specific speed turbine, 51 to 225 revolutions per minute, Francis turbine as an example. High specific speed turbine, 226 to 860 revolutions per minute, with Kaplan turbine as an example. Thank you.